I said, we're gonna do a review today, so I'll just go ahead and find it. You can find the same one. I've got them in Blackboard. Let's see if I can locate it for you. Take any algebra, count this volume just in case WebEx folks can't hear me. All right, let me see, where are we going? Good, good, good. Old tests. Oh, good. Fall 2021 is still up here. Excellent. Fall two, well, yeah, the last one I gave, that'd be easiest. You can grab any of them that you want, but let's go ahead and start this. Let me get my OneNote started. I think today we'll do those kind of lines. So we'll just go through as much as we can and hopefully we'll get through the whole thing. All right, does anybody need graph paper or rulers? Ruler, all right, I got ruler, you know I got rulers. I got graph paper too. Who needs a ruler? Everybody need a ruler? Okay. What about graph paper? Now, graph paper will be on the test. You won't have to bring your own graph paper, but if anybody needs graph paper, I've got some over here. You got a ruler or graph paper? There's graph paper up there. We're doing review today. You take as much as you need. There's gonna be several, well, 2 graphs on the test. Do up as much as I can. All right, so start with this one. Take a few minutes, see if you can get the graph. Remember, there's 3 ways of solving these systems of equations. One of them is by graphing. Then we have substitution, and then we have the elimination method. So I'm going to want you to demonstrate all 3 of them. No, for this one, just graphing. Do you think you got it? Let me know. I have the answer and I'll be happy to discreetly show it to you. That is not a universal opinion. No. It's strange what people like and what they don't like, because there were spots in math when I was coming up through high school and even college that I seemed to like, but were hated by other students, and other things that I didn't like and then they seemed to enjoy. What was that? Oh, solving equations. Yeah. That was, that's true. Green line. That's nice. If you're stuck, let me know. I'll go and do the problem instead of wait forever. All right, let's start with this first one right here. 7/3 x plus 5. I'm going to try to remind you what you do. 7/3 x plus 5. The first thing you want to do is place the y-intercept. Where is that 5 at? I start here at the origin and I go up 5. Okay, there it is. Let me get it set right. Got my point. Now, from there, you use the slope to generate the rest of your points. So tell me how I can proceed from this spot to write another point. 1, 2, 3, 4. Well, you're gonna have to go backwards. Yep. 1, 2, 3, 4, 5, 6, 7. Yeah, I can only reverse myself here. I don't know if I have a number of space for them. I don't like just 2 dots. That's not enough for me. 1, 2, 3, 4, 5, 6. Oh, that's way down there. Look at that. 2, 3. No, 2. The only reason you needed a third one was to check. Remember the phrase, the shortest distance between 2 points is a straight. You don't know the phrase? The shortest distance between 2 points is a straight line. That's an old phrase. That's yes, sir.
So since you got enough space to continue to go to 7, when you use 3, you would go to the right, 3 to the left.
No, you go 3 to the right. Exactly.
So when you did it backwards, wouldn't that shouldn't be a negative?
So when I go backwards, instead of up 7, I go down 7.
And when you go to the left,
So
3,
because I'm reversing myself is what I'm doing.
also it don't mean I have to put a negative in front of it.
No, of course not. No. I couldn't go up to 7. I didn't have it. It's blocking me. So the only choice I had was to reverse direction. I think I got the line chosen, so let me get it started here. I'm also going to clue you in about when you find the answer to this. Make sure that you use the ruler and everything. I do want these lines to be straight. You know the deal. You probably won't get credit if you don't use a ruler for this. Come on, set. Let's see if it's good. It likes to jump on me at the last second. All right, that one's all right. All right, now let's look at the other one here. Use the same idea. Tell me where I'm starting this graph at. All right, going down 4. So I go 1, 2, 3, 4. I have placed my dot. Now I'm telling you this. If you do enough dots using the slope, you will run into the answer. You'll see what I mean in a second. Now tell me how to proceed from this point. Tell me how to proceed. No, you do not go up.
So it's definitely
Down 2, and then what? No. Always to the right. Always to the right.
or like doesn't that
The
mean,
negative sign means down.
but it's always to the right.
We've decided to stick the negative with the y part of it.
I thought it was.
You could stick it with the left part, you could stick it with the x part, but then you just have to, then the y is always going up. So just remember this, always to the right, always to the right,
Even if the fraction is negative, it's still always to the right.
always to the right. Yep. All right, so let me go and get my points here. I go down 2, 1, 2, I go to the right 3 and place a dot. And I'll keep going as much as I can. Down 2, to the right 3. Now it's important. To me, I don't think I have enough dots. I don't feel good enough about it, so I put more dots. If you reverse yourself, what do? You'll go up 2 to the left 3 and look. You see what's going to happen right here? You're going to have an answer right there. You can't help it. Now, I'll do more points just because I'm that way, but technically you're done. I mean, you draw a line, it's over. 1, 2, 1, 2, 3. What was it? 2 and 3, 2 and 3. Yeah, 2 and 3. Go ahead with your question. I wouldn't bother. Look, I'm not grading you on these points, actually. I just do it because it gives me more accuracy the more you put. So while obviously I look at your lines to make sure, but the most important thing is they'll cross the right spot. You'll see there they cross, of course, at, was it -3, -2? Okay, I got my line in, good. So there's our guy. Where's my mark? So right there is -3 for X, 2 for Y. Questions about that? Maybe it might help you this way. When you're dealing with these things, it's probably best to do this. I'll write it up here. Best to do. The second one is the one. What I would do is this. Think of it as this. Like that. Can you tell which one is rolling up? It's telling you to go down. Put it so the negative is associated with the top. Just consider what the negative will make it go down. We could have done this whole theory by taking the negative and associating with the x, and it just. The important thing, you got to be able to graph, and the graph has to come out to a good spot, otherwise you can't estimate on these things. Other questions about this? Yeah, I'll entertain any questions. Right. right, then I will move on. So there's one. Oh, look, we got it right. Okay. Here's the next one, which I went and gave a hint on it. Well, if you, did I see you have to, oh, I guess, yeah, I give you two of my graphing. How's this? I didn't know I did that. Oh, I know why this also is different, because this one doesn't have them both solved for Y. So you have a little bit of more work to do. So that's why it's a different style of problem. You see what I did? I had to fix it so that they were both Y equals to something. So now, go ahead and try it and see if you can get on, do the lines now that I just did the example. Yes, sir. No, I just added 2x to both sides. Yeah. You think you gotta let me know I have the answer. You got it? Where's the slope of that second line?
Slope.
Yeah, in that case, you're gonna have to think of it as 2/1, so.
Yeah, that sounds like a fraction, that's what.
No, it doesn't have to be a fraction, so this problem tested several aspects. Yeah, that's it, precisely what business applications will do. They'll have a huge list of, so they're extraordinarily difficult problems to solve in the real world. And they'll look for all the places where they intersect. All those corner points will be the things that they test. They'll test all it. They'll do it all on a computer, and a computer will test all those numbers and let them know which one is the most efficient or best, whatever cost saving measure, whatever. I'm going to start graphing here. This first one here, tell me where the y-intercept. I'm starting at the origin. Got it. Now what? -1/4, down 1. Yeah, I'll just keep doing it for a while. Usually when it runs off the graph, that's where I end. 2. That look right? No, it doesn't, does it? It is not right. That one was wrong. Down 1, 1, 2, 3, 4. That's why you do more than points, because then you can tell if they're wrong. But if you just do 2, you have no way of knowing if you did it right or wrong. Now I'm going to reverse myself. So I'll go up 1 and to the left 4. I think one thing that probably we don't talk about enough in this is that in general, when we think of going or a graph increasing or decreasing, we always think of the x values as going to the right as it happens. So on this line, you can see that the line will generally tend downward as I go to the right. That one, I guess. Get it. All right. Second line. All right. For my second line then here, tell me where I graph it. Where do I put my initial point down at? I go down 6. Got down here. I'm not going to reverse myself. I'm running out of the graph. So then how do I go from here? As I said, if you do this correctly, you are going to run into the other spot, the other graph, and that will be the answer. See it? Technically speaking, what's the point of me doing any more points than this, really? There really isn't. I know where the answer is. The only reason I do it is because being the professor, I need to have a very accurate looking graph. But really, we only need that thing there, and we're done. Unfortunately, you don't know where that thing is until you've graphed the second line. So we've got our spot. That's all that I am, because I'm not even happy with this. That's the kind of people who become mathematicians, though. 1, 2, 3, 4. X value is 4.
Oh, because that's where the points meet.
If you plug this 2, 4, 2 into both equations, it will work.
The X and the Y.
Take the 4, for example. If you plug it into there, you'll get -1 plus 3. That will equal. Just trust pins. So this one you'll be able to do. 4, plug it in. 4 times 2 is 8. What's 8 minus 6? Wait.
So that's like the extra.
That's a check. You can check yourself on these, on all of these problems, you can check yourself. That's the beauty. You don't have that capability always, but on these ones, even the other ones we're gonna do, which are, the algebraic versions where we do them by hand, you can always check your answer. It's funny, you will not need graph paper for a while now. All right, these next ones are done. Now, if I tell you a way that I want you to do them, I'm trying to grade and see what your knowledge is of that particular item. So make sure that you solve them in the manner that I put on the test. So if you read this one, it shows, see what it says here, you must show your work which specifically shows the substitution method. If you try to solve in another method, you'll get no credit. Do you understand? Some people will do this with, this is 20 points. This is 1/5 of the test. So keep that in mind. Well, what is substitution? Can you guys remind me? I mean, I don't want to sit here. None of you guys know what it is. I don't want to remember. I don't want to just sit and wait while you guys do nothing.
So it can say why.
See that? No, that's not it. See this here? You see how y is explicitly solved for? I can take this expression right here, that guy right there. See him? I can take that guy right there and put it into that spot. Do you understand? You guys follow me? That's y, and I'm going to place it into there. I think I'm going to want regular this. So I'm going to take this quantity here, that's y, and I'm going to plug it into that thing. Don't forget to put it in parentheses. So that first equation, there's the 5x plus 2. Now I'm going to put in the y. X squared. I'll pause there. You guys follow where everything comes from. Do you understand why it's important to do this? What is the point of me doing that? Well, equation that's true, but more importantly, you look at my equation that I have, how many variables do you see in it? How many different variables? Only one variable, it's x.
Oh,
You can't solve equations that have more than one variable. You have to get to one variable before you can solve it. And so, well, what's next? You're going to solve for x. Once you know the value of x, you see that you'll now be able to plug it into the second equation to get the value of y. That was great looking at me like you're playing poker with me.
This is where I'm like, I don't got that part. We get next is where I'm like, yeah, same with you.
Do you understand? I need to solve this for x. I mean, if you're in an equation with x in it, you're almost told to solve it anyway, right? All right. 5x plus 4x plus 14. All I do is distribute.
If you multiply the 2 and the 2, it's 27.
That's right. Okay. So it's distributed property. Now I'm going to combine my x's. 9x plus 14. What do we do next?
So you add 5 to the 4.
Find like terms.
Subtract 14.
Subtract 14 from both sides. Equals negative. Divide by 9, right? Find out the x is equal to -2. Now, remember, your answer looks like this. When I bring up my answer, you need to give me an x value and a y value. So far, I have only half of the answer. How do you get the other piece?
2 to
You can plug -2 in either equation, actually.
What about the specific one?
It doesn't matter. However, there's a better and a worse one. You tell me which one is the better one to plug it into.
bottom one.
The bottom one, because once I plug x in here, I'll immediately be told y.
It's y is the
If I plug it into the first one, I still have to solve for something. You understand? I still have to do work. So once I know that, I'm gonna use, the whole point of the substitution is that this part, what happened process is that this part is really easy. So you had y equals 2x plus 7. I'm gonna replace my x with the value that we know it is. Can you tell me what that equals? Three.
That's the y.
That's y.
So
See over here?
2, 3.
Y equals, that's right.
Negative
Negative.
comes to.
Now, if you, unfortunately, this one doesn't, isn't exactly the greatest problem with me, but I grabbed it from the book. The answer, this could have been done by graphing. It could have, because look at the answer. No fractions in it, you know what I'm saying? That's, I think your book kind of whips out on a lot of the problems that they could ask. All right, so I've done the first one. Can you do the second one?
Same thing.
I'm not saying, I don't want to say anything. I want to see if you guys are capable of making that deduction. Oh, there it is. Do we think they got it? You good? You think you got it? Oh, this is 3B, not 3A. Let me change my A to a B. Well, might as well show the people at home or use it in the WebEx land. Did you get this answer?
Yes.
Excellent. You think you got it? Or are you going to check? Who else thinks they're about there? I'm going to call the mercy roll here. So yes, the X was explicitly solved for. So you want to take this quantity now and plug it into that one. So that equation becomes 3 instead of the X. I'll put my 3y is 11 minus 4y and equal 18. And then I'll multiply it out and simplify it. So when I distribute, I get 9y plus 33 minus 4y equals 18. Right, combine your like terms, so you got 5y plus 33 equals 18. Now you try to get y by itself. Subtract 33. And so we have 5y equals negative 15. We get y equals negative 3. My answer so far is x, I don't know, but y I know to be negative 3. Now, how do I want to go back and get the x? Plug it in for the one where y is solved for. So, I mean, x is solved. X was equal to 3y plus 11. So now I'm going to replace that y with negative 3. Whenever I replace a negative number, I put parentheses around it. It's a smart idea. And then when you evaluate this, you're going to get negative 9 plus 11 is 2.
So that technically x equals y plus b.
No, it's actually in the reverse of that. It's you know how you call it the slope intercept form? This format here is like the reciprocal of the slope. Because the slope would end up being 1/3, right? It's reciprocal of the slope, and that there is an x-intercept.
That's the x.
Yeah, everything in this problem here, everything's reversed. X and Y, all their roles are switched in it. So it's technically like that. You can still do it, except now your intercept is x equals 11. And your slope is not 3, but 1/3. So it's complicated, but you can do it. Come here. And then we have the elimination method. Two out there. You'll get to do your own method of choice, except graphing, because I'm guessing the answer comes out bad. I would never, all these answers could have been done by graphing. That's just annoying. It defeats the purpose of having other methods if you can use one method to solve everything.
Substitution, then elimination, your own choice.
Right, then you get to pick whatever you want to do, as long as it's not graphing. The only reason I'm doing that is because the answer probably doesn't come out good. We'll do it hopefully before the end of class, but. All right, we have about 1 minute to break. Do you guys want to do break, or do you want to go plow through this and then do a break? No, no, I'm just saying we can plow through it as slow as you want. We just might have a break at 2:20. All right, we got some brave people. All right, well, let's say, do you remember, let's start, well, I'll kind of do this one anyways, so I'll do this one. You can help me, coach me through it, and then after break, you can come and try the second one. All right, do you remember notice how everything is on one side of the equals now, so it's different than all the other problems. Right? That's why elimination is most appropriate for it. So remember how this works, you want to try to take out one of the variables at the beginning. If I wanted to take out x, for example, how would you do it? What we do is we multiply each equation by something, and we end up adding them together, hoping that one of the variables disappears.
Oh, yes. It's happening see what the.
All right, so we got, watch this. Here we have 2x plus 4y, 3x plus 4y. In order to eliminate the x's, one way you can do this is the following. If I multiply the top by 3 and the bottom by 2, I'm always going to have to multiply by something. When I do this, what is 3 times 2x? What is 2 times 3x? Right now, they're both 6x's. It's perfect. Wipe them out. One has to be negative. I really don't care what you put the
So now we're.
no, as long as one of them's negative, one's positive. That's now let me rewrite the equations. I usually go down underneath of them. I give myself some sort of an indication that I'm moving on, so I like to use these little down arrows. Rewrite them after having distributed these numbers through. So the first equation is 6x plus 12y equals 24. I'll pause there in the hopes of seeing people's faces light up and say, yes, I get that.
I don't even think about it.
Distributed the 3 through. You guys understand? So the next one, I'm going to multiply everything by -2. And you see what happens? This is the whole game right here. The whole ball of wax is this part. That thing. Because when I add them together, they will wipe out the x's. The y's are collateral. Now, when I add them together, can you tell me what the result is going to be? X is gone. What are you gonna get? Tell me what the x's are gone. 6x minus 6x disappears. Now I add the y's together. What do you get? Well, yeah, what's 12 minus 8? 4. That's right.
Got
Now, if we want to get y, then what do we do?
Well,
Divide by 4. Y equals -2. Right, so I recommend doing this. When you get part of the answer, at least it will remind you too that you have still a number to get yet. So what I do is I rewrite the whole thing. I have told you before, if you write more, you will do better at math. That, yes, look. You all take English, right? Or whatever, literature? Yeah. What does your teacher tell you that will make you better at writing? Reading. The more you read, the better you will write. That's just how it works. Because the more you read, the more you'll see different techniques that people use, and they'll just become ingrained in your mind. You'll like some of them, you'll keep those, you'll throw out the ones you don't like. Yeah, but with math, a lot of students leave a math class, they're like this. When I became a professor, that went away. I was cured.
I always thought math was like, just get straight to the point.
Oh, you haven't seen the theoretical math. I'm gonna, most people don't. All right, now I want to wipe out the y's. I've already taken care of the x's. Tell me how to wipe out the y's. This is so easy, but I'll let you tell me what your idea is. All I really have to do, if I just multiply one of them by -1, won't one be 4y and the other one be -4y automatically? So that was an easy one. If you can see it, but some people, if you're doing it just by rote, they might multiply the first one by 4 and the second one by -4. That's how it'll work. Of course.
Is it better to do it?
There's no, this,
Okay.
no, it will be slightly better if you do it this way because you'll have to simplify less in the end if you have a fraction. But for a lot of students, they want just one method that works for everything, and that will work for everything, but what I told you will work all the time. Now, let me pause for another second and tell me, was it the smartest thing in the world for me to choose the second one to be negative? That equations together, what do I get? What I'm making is, had I put the negative up here instead of that, that would be a positive x. And I wouldn't have anything else to do. But I do have an extra step, don't I?
Because you gotta change it.
Yeah, negative x equals negative x is not good enough. So had I thought a little bit more before I made my choice, I could have made this problem so fast. All right, when you come back, we'll let you do the B. As usual. Yeah, go ahead. Reason why I chose negative one. Make it opposite of positive. Need to make that, this is exactly what I. Okay, I get.
What did I do?
Okay.
I did 4 instead of 1.
That's fine. So, right. So that's negative 8x minus 16. Where'd the y go?
True. I didn't write the Y.
Not only that, you didn't multiply that one by 4 either, did you? Because that would be positive 16y, wouldn't it?
Yes. So I didn't multiply it.
Well, you didn't, for some reason, that 12, you copied to that part too, I don't know why. It'll work, trust me.
Okay.
You'll get a positive 16y there. All right, let me grab this one here. You know what, I think it probably won't be a bad idea. I'll leave it here so that you can see what I did. And maybe that will inspire you. So try the part B. Remember, you have to use the elimination method on these problems. That's requirement.
Once you got it, let me know. I got the answer and I'll be happy to come around. I will display for the WebEx people in a minute or two.
Bet you that will work. That credible. Two times.
Yeah, no, okay.
Anybody else have any check?
So, well,
Spending.
For the WebEx land, let me see if I can get it. That's for WebEx land. All right, now the problem that I see with most people is you want one method that works for everything. And I'm here trying to tell you, there are times that you can use logic to save yourself some effort and things like that. And so there might be too much going on at once. You can, as I said, you can come up with one method that will work for everything. In this problem here, let's take out the X's first. So right now, if I add some people, when they take the test, they actually just try to add the equations together and see what happens, but that's useless. They don't, nothing cancels. Well, they write something in the hopes of, I guess getting credit for something. Anyways, This is called, right, exactly. This is called elimination. So we want one of the letters to disappear in this process. Let's start with the X's. Just think it through. Told you. Switch the coefficients. Why use that word before? Okay, I can use the coefficients like this. I can take the one from below, 2. Take the one from up here. This doesn't matter. Relax for just a second now. If I were to multiply this right now, I would have negative 6x, and I would also have negative 6x. I add them, I'm not going to change the 2 to a negative. You could also change the 3 to a negative. Doesn't matter. One of them's got to be negative. If I do this, then I have negative 6x, positive 6x. One will go away. Part of the things that I'm seeing people are not doing, you've got to remember this. You need to draw yourself the rainbow. Don't worry. Nobody's going to come in here and laugh at you. So when you do that effect, I get, for the first equation, I get negative 6x plus 4y equals 26. Great. Now, the next one is going to be negative 6x, the way we designed it to do that. I mean, positive 6x. We designed it so these would cancel. But then when I go over to the next one, I'm going to get negative 15y. And then I'm going to get positive 18. That's fine. It'll still work out. So. And that's another, there's another issue too. If you're trying to memorize one method, it's tough for me because they all of them have multiple ways of solving them. So it does make that issue hard. When I add these together, the 6x's go away. And what do I have for the y part? Negative 11y. Add those two. Add these two. To figure out the value of y, what do you do now? Divide by negative 11. So far, here's what I have for my answer. I'm making myself space. I have just the y part. I need that part yet. Okay, now, we're going to take out the y's, so we can do what we've done before. What numbers am I going to put here and here? I'm aiming for the y's. Expect the answer to that question.
I'll say one.
What number do I put here? How about down here? Now, stop. 5 and 2, don't worry about the negative and positive, just put those 5 and 2 there. Now let's decide. If I do this, think about what happens when I get to the y's. When I do this, how much y am I going to have? If I do this, how much y am I going to have? I don't want that, do I? One of them's got to be negative. Which one? I don't care. Just for variety's sake, I'm gonna multiply the top one by negative. I usually do the bottom one, it doesn't matter to me. All right, so when I multiply this through, I'm gonna get positive 15x minus 10y equals negative 65. And then when I send this through, I get negative 4x plus 10y, that's by design. All the way over here, I'm going to get negative 12. So why is this appear? And I'm up with 11x equals
Negative 77.
You kept it.
So X is equal to negative 7. And once again, if you have some time on the test, plug those things into both equations and make sure they work. Yeah.
First part, where you got the 8 to 26 plus the 18. How would you do that if your 18 is negative like mine? 18.
So then this here, your negative 18 would have been because you multiplied by a positive 3.
Right.
But then up here, you would have multiplied by a negative 2.
Uh-huh.
That would have been negative 26. That's why it's still gonna come out with negative 44 in your case.
Oh, no, that's
All right.
I have a question.
Yeah, go right ahead.
How did you get negative 11 for your answer?
Negative for the Y.
Yeah, negative 11.
Look at
Shouldn't
the
it be
Y.
negative 4?
Oh, yes, she's right. Very good. What do they call that in the movies? They call that where everybody sees the same effect and they will. So I forget what they call it. That's that negative 4, isn't it? She's right. Bad. You guys understand this is negative 4? You guys wondering this before? Or did you just kind of roll with it? Okay, that's great to hear. All right, yeah, I'll plug them in the issue order. I'll just check them real quick. You know what? Hold on a second. I said, I walked around with the answer. And then I went and did the wrong one up here. Negative 7, negative. Doing math on low sleep is not a good idea either. All right, on to the next one. This one you get to do whatever you want with. And I don't care if you want to graph, I probably wouldn't care actually. If you can get the answer to it by graphing, I don't care. I have this feeling though, you're not going to get it. Well, no. Oh, yeah, go ahead, try graphing. All right, be your go-to method. So I will give you 10 minutes to negotiate this problem. I've tried to cut out any work that I did previously. I honestly don't care if you use graphic, that's fine with me. You know, did I ever tell you about the time when I was in karate back in high school? You look at me now, you're like, there's no, well, no, it's been a long time since I've been in it, so I'm not in shape anymore. But one of the guys that was really good, when I would spar with him, he would attack me and yell and scream when he did it to scare me, right? To frighten me. You're letting this problem frighten you and you're not seeing an easy solution, is what I'm going to tell you.
This is funny because I want you to look at the screen. Could you look at the screen for a minute? The thing that I did not, the thing that I failed to do was get rid of that plus sign. All right, listen to me. Do you guys see in the first equation, there's 1/2 y, right? What is in the second equation? That you can eliminate it just by adding them together. You'd have to do. If I have a whole number and I take 1/5 away, it's 4/5 left. The way it looks is 1/5 minus 1. Do you agree? A negative, where is it? Oh yeah, there's -1 for the x, right? So this 1/5, what if I change that -1 to -5/5? Still the 1/5. What if I added them now? Add two fractions, what do? You leave the denominator. What is 1 minus 5? But I thought easier, in my mind, it's easier to say 1 minus 1/5 is 4/5, isn't it? It had to be negative because there was a negative. So anyways, how do you solve an equation like this? I'll take your answer in a different question in a second. How do you solve an equation like this? Look, I got 4 hours of sleep last night. Don't tell me I'm sharper than you guys. Well, remember, this, the easiest way to solve these is to multiply by the reciprocal. Right, but to get rid of the negative, I have to do that. So I'll do this 40/1 times -5/4. So I multiply both sides by -5/4 because what's the point of that? See what happened to the left side? Wipe away. We've been multiplying by the reciprocal since the beginning of the semester. Well, I have at least. So now when you do this, do you see that you can cancel a little bit here? 10 times -5 is -50. If you would have graphed, do you think you'd have gone out to -50? Probably not. That's why. All right, now that you got x, what I would do, since there's so many fractions, what I would do is I just plug it into the second equation or the first. I think I'm gonna plug it in the first equation. So this one right here, this horrible, absolutely nasty looking equation. I'm going to replace x equals -50. So I'm going to combo substitution and elimination. That's advanced.
That is not.
50/1. You see what happens between the 5 and the 50? I'm going to solve for y. I'm going to add 10 and then multiply by 2. So I'm going to get 1/2 y equals 22. Multiply both sides by 2. 2/1 over here if you like. 2 over on that side if it makes it easier. You see, I'm technically multiplying by the reciprocal, aren't I? These go. Y equals. Equal. Obviously, you didn't think that my method was the simplest one. So what you can do, if you don't like, so here's the point here. You can still do it according to our regular methods. You don't have to be tricky like I was. Let me show you what you could have done. If you don't like the looks of them, you can always fix them so they look better. Let me re-grab them. We're going to redo it. I think I have the time for that. Actually, no, didn't I copy it already? I did. I can just probably paste it again. Yep. Now, let me redo this problem. Except before I do anything. Equation by 10. Second equation by 2. That's what I was going to do. Why did I want my first one? What does 10 have any? It's with least common denominator. The word itself is a lot to run. Tweet down, but. Do you understand? Do you remember we had these with all these fractions? I said if you multiply by the least common denominator, all the fractions would disappear. Remember that? If what's 10 times 1/5? Did you tell me? 10 times 1/5 x plus 10 times 1/2 y equals 10 times 12. What is 10 times 1/5 equal? You can always do this. They cancel and gives you 2x. What about between the 10 and the 1/2? What do you get? 5. What about on the right side? When you multiply any number by 10, you just add a 0 to that number. Same thing down here. So I'm going to have 2 times negative x minus 2 times 1/2 y equals 2 times 28. I don't. The only reason I multiply by these numbers is to clear all the fractions out. We used to do that all the time with equations. Multiply by the least common denominator, wipe out every fraction of the equation. What am I doing? Oh, yeah. Let me write it again. We have 2x plus 5y equals 120. I have negative 2x. These two cancel and I get minus y equals 56. Now let's try this again. If I ask you to solve this system of equations, tell me what you would do first. Well, the two already set are above, aren't they? I can just add them together, right? Can't I have to wipe out the x's? I don't have to do anything except just add them. The x's are done. So these x's go, and I have 5y minus y. That's 4y equals 176. Divide by 4 to get y by itself. What's that going to be? I can tell you. 44. Now, if you want, you can continue the same method. I'm going to go 2x plus 5y equals 120. And then I have, negative 2x minus y equals 56. If I want to wipe out the y's now, how could I do it? Oh, I got, no, not by one, no. Well, the first one by one, if that helps. Is that what you're thinking?
I was thinking, I'm thinking something like that.
The second one by just 5? Because that way you'll get a 5y and a negative 5y. You don't need that one. You just leave the first one alone. We have 2x plus 5y equals 120. Negative 10x minus 5y equals 280. Add them together, what's going to happen? As we expected, the y should cancel. Give you a negative 8x equals 400. Divided by negative 8. And you end up with negative 15, what we got before. So my advice on the nasty one is to multiply out and get rid of the fractions first. Unless you want to do, I usually leave some little tricky thing in there. If you recognize it, you can use it. But by the looks of it, by your faces, it doesn't look like you want to do that.
Yeah, let's get it.
That's the unfortunate thing about this level of math classes. You're trying to memorize methods instead of feel the theory underneath. I understand. Well, there's only one more, I think, and that's another graphing one. No, I forgot about these things. You remember these? Heck, I didn't even remember them. Do you remember when you could almost read the first one and set up an equation based on that? Let me show you what I'm talking about. Move this up. Let's take a look at A. I'm going to write something down and see if you can follow it from the equation. On there. These numbers, read the question and see if these numbers all jive with some parts of the question. 5 pounds of jelly beans plus how many pounds of trail mix plus 6 equals how much? Follow the first equation? 5 pounds of jelly? Jelly.
I said the same thing.
I don't care. 5 pounds of J plus 6 pounds of T is $28. You understand?
Yeah.
Now, can you get the second equation in the same fashion? So let's see the second one. 3 pounds of jelly, see it? Plus, how many pounds of trail mix? So 2 is how much money, unfortunately? 5 pounds.
I understand the equation.
Okay.
Well, if the second one is half the amount, shouldn't the size, the quantity be half of it?
No. I think that would be one way to do it, yes. But no, it can, depending on the equation, it's not as simple as you. So, well, just, are you good with these?
Yeah, that I understand.
Okay, so these should be, what I'm getting at is these equations should be simple.
get it. Remember, everybody says, what's the hardest part about word problems? Getting the equations, and they're there. So now you can solve this using any method you want. What do you think you would use? Elimination, because they're all on the same side. Because of time, I leave the details to you. You need more practice at that anyways. Do you think you can do the same thing with the second one? In reality, these two problems, you may not know this, but these two problems are mathematically the same, almost identical. $78, all right. There's an issue with that, but I went 78. Keep going, keep going, keep going, keep going. It depends on what this other side you're gonna say it equals. 0.9 times. See, but you're mixing your decimals. It shouldn't be 0.9, it should be 9. Since he decided to go decimalist, the whole problem. I don't think that's such a smart idea, but honestly. Okay. That way, this side then is going to be 0.9 times how much? 140. Now, can you give me the second equation? Give me another, you need two equations for these. It's in there. Uh-huh. Now, where did I get that one? Over 140 ounces, right? If she wants 140 ounces, A is the amount of ounces of one, B is the amount of ounces of the other one. If you add them together, shouldn't it be 140 ounces if that's how many ounces she wants? So yeah, the second equation of these are always a big one. You know, 140 ounces is how much she wants to make. The first equation, you've got to use your percentages. And the second equation is just an amount equation. And there's, once again, a number of ways of doing these things. I'm not even sure. I mean, there's so many. I don't. You ever had that thing like, oh yeah, name me money. Like, well, there's so many I can't even come up with one. And I can't even think of a method right now. But what I might do, probably, is I guess I would multiply the second equation by like negative 0.7. That way you'll be able to wipe out the A's. I'll leave the rest of it to you. The last one is what is it? I think there's only one left. The answers are here, so you can check yourself. This last one right here. Up in there. All right, notice that both of these are already in the format you'd want to do them for graphing. Can you tell me this one right here? Tell me how I would graph this. What point would I lay down first? How would I get there?
I knew that was gonna happen. Cruelty. Actually, I want to think about this. I need to get myself at least -9. The other one is +5, so all right, that's fine. Is this saying the same? I'm not, it's not allowing me, is it? Oh wait, is it getting bigger? All right, that's fine. Let me try again. -9, 1, 2, 3, 4, 6, 7, 8, 9. All right, once you have that 9, what do you do next? Down 2 and to the right 1.
Goes negative.
Uh-huh.
Okay.
Down 2 and to the right 1. And I'm going to reverse myself over here. Should it be a solid line or a dashed line? Right, it should be solid. You're exactly right. Let me do one more here and I'll go put my line in. Solid line. Got it. Now, there's one more thing. See, it says here, do you see y is greater than or equal to? Do you see where I say shade above? So do you remember what I was doing when I was shading above? You're trying to find an overlap. That's what you're. Something like this. Shading above, I'm shading on here. All this stuff is. Next. For the second line, I realize I'm going fast, but we're really tight on time here. This -2x plus 5, tell me where I should start it. Right, so start it and go up by 1, 2, 3, 4, 5. Did you notice they have the same slope? Did you notice though that they have the same slope? That means they're not going to connect, are they? I reversed myself before I went forward. Yeah, I'll do one right here for good measure. I want to grab this. This. Is this line solid or shade or dashed?
That's right.
Dashed because it's greater than. Remember, where's my thing? That greater than means it's a dashed line. So for me, that means I have to do this game. Not that one. Well, how should I shade this one, above or below it? Did it say less than? So you should say below. And I use horizontal lines for that. When I do the other one. So since we have to be below, I'm going to ignore the other line, and from here, I'm going to draw my horizontal. And then you'll be able to see region that's intersected. But we call it the overlap. Can you see the overlap? It's the checkered area. You don't have to do anything more. I'll know the area, but you know, if you want to color it in or whatever to show to me, you know, it's fine too. Now, between now and the test, you can feel free to call me, whatever. Nobody ever called my office hours. I can even do a WebEx if you go in the office, we can go right in, like we're in front of each other. You know where to find it? I would also, if you could, you know, you're allowed to go back to the homework and do any of the problems you want without changing your grade. Do you understand that? You can go ahead and try another till you're blue in the face. I recommend as much as you can practice these problems. That's all I got. Say again? Oh, no problem. Stop this and get